Hey everyone, good afternoon, good morning, good evening to whatever time zone you're in. So this would be my second project with this course, Managing Machine Learning Projects. So this would be my agenda: opportunity evaluation, crisp TM business understanding, solution validation plan, ML system design, and potential risk in production once we deploy this. So first slide talks about opportunity evaluation. So the problem statement I chosen, or the problem I chose, is a false insurance claim. So the problem is prevalent in insurance industry, which is leading to significant financial losses for insurance companies and also causing some higher premiums for policyholders who are very honest. Is there a problem? Yes. And can machine learning help solve this problem? Yes, it can definitely solve this problem by detecting anomalies, predicting fraud, and automating investigations. And does someone care for this solution? Yes. Insurance companies do want to reduce their losses, and policyholders doesn't want to uh, increase their premiums, and regulators and law enforcement want better society. So, as per crisp DM business understanding, I define these problem, success, and factors which are involved in this machine learning solution. So, the target user, as I said, insurance companies, fraud investigators, and regulator bodies. And why do we need a solution for this problem? Because insurance fraud can increase operational cost for the companies and also higher premiums for customer, and there is a risk of customers losing trust in the company as well. So the current solution for this problem is a manual investigation. There are some rule-based systems and some statistical methods for detecting anomalies. But these things are time-consuming, labor-intensive, and not always effective. So there are some gaps in the current state. Manual process lead to error, and rule-based systems can be easily overcome by fraudsters and lack of real-time detection. So what would be the success? The success when we implement this solution would be the reduction in number of false claims, a decrease in financial losses and lower costs, and also improved customer satisfaction. And what could be the constraints for this solution? So the constraints could be the data privacy, integrating with the existing legacy systems, and having a quality data for training our models and budgets. What could be the outcome metrics? Outcome metrics could be fraud detection rate, false positive rate, cost savings, so on. And regarding output metrics for the model accuracy, the processing time, and the investigation efficiency, so on. And what are factors involved in the solution? So we need to gather some domain expertise from experts and also identify potential relevant factors related to claims and customer profile and behavior patterns, so on. Moving on to solution validation plan. So this solution is basically to detect and prevent false claims. So there would be 5 steps involved in this. First step is initial experiment where we would validate the solution and we also would be splitting data and also creating a baseline model. And in the second step, we would be doing feature engineering and model selection where we would create features, model, and validate our parameters. And in the third step, we will create some metrics and analyze the error and refine our model. And then in the other fourth step, we'll deploy and monitor. And in the fifth step, we would be doing A/B testing and improving our model further and also collecting stakeholder feedback. And regarding system design, I've chosen to choose cloud, online learning, and offline learning and online predictions. This is because considering data volume and computational resources, scalability and integration, we need a cloud-based system. And regarding why I chose learning, offline learning, because there is a lot of data. So offline learning will help us to properly do the testing and deployment. And regarding predictions, we need online predictions because then only we could reduce our time and reduce operational cost. And regarding potential risks, there could be different issues like training serving skew, latency, data drift, and concept drift. Sources for training serving would be data pre-processing, latency would be model complexity and infrastructure, and data drift could be changing fraud patterns and external factors, and concept drift could be evolving fraud techniques and policy changes. That is itself because I just have 5 minutes. I can't go in detail. Thanks everyone.